Hey students, this is lesson 512. In this lesson we're going to learn how to simplify expressions. So what we're looking for here is the simplest way to write an expression. We're going to use the ideas we learned about distributive property to help us do that. I'm going to start by, I'm going to go down here and just define something for you, our vocabulary. And we're going to be using this word a lot for the next few days and probably the rest of the year. Like terms have the same variable raised to the same power. All right, so first thing we're going to do is identify what are like terms. And we're going to look at all of these problems here. So they have to have the same variable raised to the same power. So I'm going to use a different color to underline like terms. Right here, the 6x and the 2x, those are like terms, because they both have the variable x to the first power. And the second problem, the ones that have the same variable with the same power are the minus 2k squared and the k squared. K to the third has a different power, so that's not a like term. Okay, and in this last one, or in C, we have anything that is a constant term, there is no variable on it, those are always like terms. So all those are the like terms in that problem. The 4z and the negative 5z squared are not like terms. And then this last one, the 5xy and the 2xy are like terms. Now, the reason why we want to identify the like terms is because if they have like terms, we can actually simplify the way they look. And I'll give you an example here. Let's say we have 3x plus 7x. Those are like terms. They both have the same variable to the same power. And if we think about what we learned from the distributive property, notice that x is multiplied by both of these. So this is really the same as 3 plus 7 in parentheses multiplied by x. Remember that you distribute the x with the 7 and the x with 3. And so those are equivalent. And 3 plus 7, I can just simplify that to 10x. So this expression, 10x, is the same as this expression. All right, I'll show you another one here. Let's say we have 5x squared, and we're going to subtract x squared from that. All right, again, these two are like terms. They both have the same variable with the same power. And again, using the distributive property, notice that they both have a factor of x squared. So I can write that using the distributive property as something, two things subtracted and multiplied by x squared. And the two things are the coefficients 5. And remember that if there is no coefficient there, it's actually a coefficient of 1. So 5 minus 1x squared, which simply can be written as 4x squared. Well, what I'd like you to notice is that when they have like terms, I'm just really combining the coefficients. The 3 and the 7 make 10. The 5 minus the 1 make 4. So if we have like terms, we can really just combine the coefficients of those like terms. And you don't have to do all the distributive property like I did if you just know that. And the other thing you should know is if they're not like terms like these two, 5x squared plus x, you can't simplify that. So this can't be simplified, and because the distributive property wouldn't work here. What I mean by that is x squared is not a factor of both those, so I couldn't write it like I did this one. All right, so let's go back up here and let's simplify all of these. We underline the like terms. All we have to do now is combine the coefficients. So coefficient here is 2 plus 6 is 8x. And the 4y is not a like term, so that just stays separate. Okay, combine these coefficients. When it's a minus in front of it, it's actually a negative coefficient. So I have negative 2 plus, and remember if there isn't a coefficient, it's 1, 1k squared. Negative 2 plus 1 is negative 1. So I'm going to write 5k to the third plus negative 1k to the second minus 1. And we could actually write that as 5k to the third minus 1k squared minus 1, even a little simpler like that. All these are like terms, combine them. 12 plus 10 is 22, minus 8 is 14. And then these, the other parts are not like terms, the minus 4z and the minus 5z squared. So we're just going to write minus 4z minus 5z squared, and that's as simple as we can get. Combine these coefficients, the 5 and the 2 make 7xy, and then minus 4x plus y. All right, I want to show you one more example of how you simplify when you have subtraction in parentheses. And I'll do those examples up here for you. One like this, 5 minus quantity 3 plus x. Okay, when you're dealing with parentheses like this, remember that in the order of operations you would be expected to add these two together first. So really I'm subtracting all of this, all of the quantity 3 plus x. So without parentheses, I'm actually subtracting 3 and I'm subtracting x. And now we can see that we have like terms there. 5 minus 3 is 2 minus x. Okay, I'm going to do one more like that. So write down this example, 14x minus 3x times the quantity x plus 5. Okay, in this one, we have subtraction here. Some of you are probably thinking, oh, look at there, there's like terms, we can just subtract those. You can't because of this multiplication right here. You have to do the multiplication before you do the subtraction by the order of operations. So we really need to distribute this 3 in here. And it's a minus 3, so just to remember that subtraction is adding a negative. And so I'm going to distribute the negative 3x. So I'm going to just write down 14x plus, and now I'm going to distribute negative 3x times x is negative 3x to the second. And then distribute negative 3x times 5 is negative 15x. Now I can look for like terms, and I have them right here and there. And so I can combine those coefficients. 14 plus negative 15 is the negative 1x plus negative 3x squared. And it does look a little bit better if you simplify this, adding a negative, just make it a subtraction. And you can actually get rid of the coefficient of negative 1 too, because 1 times anything is just the number. So make it just negative x minus 3x to the second. And that's as simplified as you get. The power on x is 1, actually. The power on this x is 2, so those aren't like terms. All right. Let's call it a lesson there. We'll talk more about this in class next time I see you.